Hello friends, welcome to Learner's Planet. Friends, this is our fourth session for algebraic and logarithmic inequalities. In the last three sessions, I have discussed all the basic things regarding this topic. Uh, in the previous session, we have discussed some basic and in fact moderate level questions. In this session, we will continue doing the problems. So once again, my suggestion would be for you is just try to do the problems on your own before you watch the solution, right? So this way you will be able to practice with me. You will be able to gain confidence in these type of questions, right? And once again, I would like to remind you, all the questions are very well picked up, very important from CAT and Z point of view. So do them sincerely, do them religiously. Okay, so let's begin the session. Let's take the first question. Since the basics are already clear, if you have not attended the previous session, but then please attend all the three sessions, unless otherwise this session will be difficult for you to understand. Okay, let's begin. Now this is a problem from CAT 2018 paper. The smallest integer n such that n cube minus 11n square plus 32n minus 28 is greater than 0. So once again, it's a cubic equation. So first let's try to find out the roots. So here 32 and 1 is 33 and 28 and 11, that is not matching, not 33. So let's see for n is equal to 2. So here 8 minus 11 into 4 plus 64 minus 28. So here it is minus 20 and here it is plus 20, so it is 0. That means x minus 2 is a factor. Okay, so let's let's find out the quadratic expression now. So here square 1 into 2 minus 11. So 2 minus 11 is minus 9n. Minus 9 into 2 is minus 18 plus 32. 14 2s are 28 minus 28, 0. Okay. So it can be further factorized, n minus 2 into n minus 7. And earlier we were having n minus 2 as a factor. Okay, so precisely it is n minus 2 whole square into n minus 7, and we want it to be greater than 0. Now n minus 2 whole square, this is a perfect square term, so whatever the value n takes, it won't make any difference if we want this expression to be greater than 0. So we can skip this, right? So n is greater than 7. So the smallest integer for which it is greater than 0 is 8. Okay, because n has to be greater than 7, so immediately after 7 the next integer is 8. So that problem was very simple from CAT 2018 paper. So if you are clear with this concept, you can do this type of problems in less than 20-25 seconds. Okay. Now the same type of problem, it has been asked in bit different manner. For how many integers n raised to 4 plus 6n is less than 6n cube plus n square? So what is the first step? You just rearrange all the terms and take all the terms on left hand side. So n4 minus 6n cube minus n square plus 6n, and it should be less than 0. So I can take n cube as common. So here it is n minus 6. Then minus n as common, then I'll have n minus 6, and that is less than 0. So here we have n cube minus n. So n cube minus n, I can further take n as common. So it's n square minus 1 and then n minus 6. So we have n minus 1, n plus 1 and n minus 6. Okay, and it should be less than 0. So just mark all the points: 0, 1, 6 and minus 1, right? Now we want this expression to be less than 0. So from minus 1 to 0, union 1 to 6. Right? Now we have to count the integers, and we want this expression to be less than 0. So minus 1, 0, 1 and 6, they are not be included. So between minus 1 and 0 there is no integer. So skip this. Between 1 to 6 we have 2, 3, 4 and 5. Right? At 1 and 6 this expression will be equal to 0. right? That means this expression is equal to this expression, but we want this expression to be less than 0. So we'll skip 1, we'll skip 6. So your answer is 2, 3, 4, 5. That means how many integers? 4 integers, right? So the problem is very simple, and this is also from the previous year paper. So I hope this thing is clear to you. Now this question, x upon x minus 3 is less than equal to 1 by x for how many integers? So once again, the problem is similar. You can try it on your own. Then match the solution. Just take all the expression to the left hand side and take LCM. So x upon x minus 3 minus 1 upon x is less than equal to 0. So here x square minus x plus 3 by x minus 3 is less than equal to 0. Now here we can see the numerator x square minus x plus 3, it is always greater than 0. So roots of this equation, this quadratic equation, are not real. That means this expression will always be x square minus x plus 3, always greater than 0, right? So this numerator is always positive. That means if we want this entire expression to be negative, that means the denominator should be negative. Then only this entire expression would be negative. That means x minus 3 should be less than 0. It should not be equal to 0, because we cannot have 0 in the denominator, right? That means x minus 3 should be less than 0. So it's 0, here it is 3. So x should be between 0 to 3. Now since we have been asked how many integers, so between 0 to 3 we have 2 integers, that is 1 and 2. Right? So the problem is very simple. You just have to be careful over here that x square minus x plus 3, this expression will always be positive because the roots of this equation are not real. Okay? So this is the curve we will get like this. It will not intersect x-axis at all. So neither it will be 0 nor it will be greater than, less than 0. It will always be greater than 0. Okay? So two integral solutions we will have for this inequation. Now this is TITA problem from CAT 2018 paper. If a and b are integers such that 2x square minus ax plus 2 is greater than 0 and x square minus bx plus 8 is always also greater than equal to 0 for all real numbers x, then the largest possible value of 2a minus 6b. So first of all, if this expression is greater than 0, that means roots of this equation are not real. Right? So this equation not real, and similarly roots of this equation are not real. But it is greater than equal to 0, so roots can be real. So the graph can be like this. Okay, it may touch, but it is just above x-axis. So x square minus bx plus 8, it is we have two solutions for this. So in this case, b square minus 4ac is less than 0. So what is b square? That is a square over here. That is coefficient of x. Okay. So b square minus 4 into a, that is a is coefficient of x square, into c is 2, and that should be less than 0. That means a square minus 16 is less than 0. That means a minus 4, a plus 4 is less than 0. So a should lie between minus 4 to 4, both of them non-inclusive, right? Similarly, x square minus bx plus 8, we want it to be greater than equal to 0. That means b square minus 4ac, precisely discriminant I am talking about. Do not get confused between a and b. Discriminant should be less than equal to 0, because we can have this expression greater than equal to 0. So discriminant must be less than equal to 0. So b square minus 4 into 8, it should be less than equal to 0. Okay. So here we can see b square is less than equal to 32. Okay, so b can be from b is also an integer, so it can be from minus 6 to, it should be, b should be minus 6. Yes, it should be less than minus 6, and uh, greater than minus 6 and less than 6, right? So b square will be from minus 25 to 25. Okay. Now since we want 2a minus 6b to be the largest, so 2a for a we can take the maximum value, that is 3, because minus 4 and 4 both of them are not included. So here it is 6, and for b we can take the maximum possible value, that is 5, because minus 5, minimum possible value is minus 5. So minus 5 into minus 6, that will give us 30. Okay. So largest possible value is 36. Precisely, since we are deducting 6b from 2a, so the deduction, the quantity that has to be deducted should be the smallest, then only we will get the largest value, right? So this should be the highest and this should be the lowest. So a will be highest, a can take the highest value as 3 because 4 is not included, and b can take the smallest value as minus 5 because minus 6 is not included, right? So minus 5 into minus 6, that is 30, and a is 3. So 6 plus 30, 36 is the correct answer. And it was TITA problems, you cannot take the help of options, right? So you'd be knowing how to solve the problems based on inequalities. Clear? Now what is the largest positive integer such that n square plus 7n plus 12 divided by n square minus 12 minus n minus 12 is also positive integer? That means we want this expression to be greater than 0. Okay, so what I do is, and it should be integer also, right? It has to be greater than 0 and it has to be integer, and we can take only integral value of n, right? So first of all, let's factorize it. So here it is n plus 3, n plus 4, and here it is n minus 4 and n plus 3, right? So n plus 3 and n plus 3 is cancelled, but you have to be very careful that you can cancel n plus 3, but in any case n cannot be equal to minus 3, because that it will be converted to a 0 by 0 form, right? So here n plus 3 by n plus 3, and now we want it to be greater than 0. So n should be below minus 4 or above 4, right? But n has to be positive integer, so we are skipping the values below minus 4, so we can take just values above 4, right? So 5 onwards, n should be 4 to infinity, right? All integral values. Now n is integer, that is perfectly okay, but we want this expression n plus 4 by n minus 4 also as an integer, right? So we have to select those values only, for those values of n for which n plus 4 upon n minus 4 is an integer, right? So n plus 4 upon n minus 4 is an integer. Now how to do that? So whenever you have to find out for a particular expression when it will become an integer, what you can do is you just try to convert the numerator equivalent to denominator. So what I do is I deduct 4 and add 4. 1 4 is all deducted 4 and added 4, and 1 4 is already there, right? By n minus 4. Okay, so now it is n minus 4 by n minus 4 plus 8 upon n minus 4, right? Now this is already an integer. Now we want this to be an integer, that means n minus 4 should be factor of 8, right? N minus 4 should be factor of 8, right? Then only it will be an integer. 8 upon n minus 4 will be an integer. Now we have to calculate the largest positive integer of integral value of n, right? For this to be an integer. So 8 we can have, and this n can be positive only. So we can have the value of n, suppose I take as 16, then 16 minus 4, that's 12, so not be a factor. So if I take n is equal to 12, right? So 8 upon 12 minus 4, that will give the value as 1, right? So the largest possible value of n for which it will be an integer is n is equal to 12, right? After n is equal to 12, this expression will be n minus 4 will be more than 8, right? So if it is more than 8, you will not be get an integral value. This part is already an integer, we want this part to also be an integer, then only this entire expression will be an integer. Okay, so this is a problem from CAT 2019 paper. So you can even take the help from options. 16 and 12, out of these two you can choose. You can choose 16 as I have chosen. So 16 minus 4, that's 12. So 8 by 12 is not an integer, then we can take the next option, that is 12, right? So I hope this concept is clear. You can see that how many questions from this chapter inequality have been asked in CAT paper in last 3 years, last 3 years precisely if I talk about. Now, for how many integral values of x the given curve will not intersect or touch x-axis, it is also given that x is greater than 1 and less than 12. That means this expression we want to be greater than 0. Then only it will neither touch nor intersect x-axis, right? So first of all, let's factorize it. Now let's factorize it. So 1 and 8, 9, and 5 and 4, 9. So x minus 1 is a factor. Then x square 1 minus 5 is minus 4, minus 4 plus 8 is plus 4, right? So and then it is 0. So here it is x minus 1, x minus 2 whole square, and we want it to be greater than 0. So again you can skip x minus 2 since it is a perfect square, so x should be greater than 1, right? So but we have been given that x can take values from 1 to 12, right? But and we want x to be greater than 1. So how many values x can take? From 2 to 11. Okay, in all 10 values. So problem is very simple. If you know this concept that this curve will not intersect or touch x-axis, that means the expression is positive. That means this expression is positive. That means you have to find out the values of x for which this expression is greater than 0. Okay, if it just doesn't intersect but it touches, then you have to consider greater than equal to 0. In that case, 1 will also be included if this condition, if there is a mention, if it is mentioned this is condition that x is greater than equal to 1. But we have been given x is just greater than 1, so we just have to skip that also, right? So you can decide the solution accordingly. If it is greater than equal to, if it is less than equal to, only greater than, only less than. According to that you can decide. So for this particular problem, since x is lying between 1 to 12, neither 1 nor x cannot take either of them as values 1 or 12, and x has to be greater than 1. So x can take from 2 to 11. There are 10 values, right? Now this is a problem from CAT 2017 paper, the minimum possible value of the sum of squares of the root of equation. So sum of the squares that basically I have already discussed this problem, that we can use the concept of maxima minima. So alpha square plus beta square, that we have to find out. So that is actually alpha plus beta whole square minus 2 alpha beta. So alpha plus beta whole square is a plus 3 whole square minus 2 times alpha beta, that is product of the roots. So here it is minus a plus 5, so it will be converted to positive a plus 5, right? And we have to find out the minimum value of this. So we can expand this, a square plus 6a plus 9 plus 2a plus 10. So here it is a square plus 6 and 2, 8a plus 18. Okay, I convert that to x square, so then we can differentiate it easily. Whether you find out the value of x or a, doesn't matter, right? Whatever the value of x you are getting, we are these two are entirely different equation, so it really doesn't matter. So for that, to find out the minima, we need to differentiate it. So 2x plus 8, and it should be equal to 0. So x is equal to minus 4, right? So that is f dash x, or first derivative. So second derivative will be 2 only, f double dash x. So that's a positive quantity. That means at x is equal to minus 4, you will get the minimum value of this expression, right? So the minimum value of this expression will be obtained by putting x is equal to minus 4. So minus 4 square, that is 16. Then 8 into minus 4 minus 32, then plus 18. So 18 plus 16, 34 minus 2, 32. Okay, so the minimum possible value of sum of squares of the roots of this equation is 2, right? A 30-second question from CAT 2017 paper, right? So if you know the maxima minima theory, you can do it very easily. Now this is an interesting problem from CAT 2017 paper. A, B, C, D are integers such that a plus b plus c plus d is equal to 30, then minimum possible value of this expression. It's again a TITA problem. So we have a minus b whole square, a minus c whole square, a minus d whole square, right? So if we can make each of them as 0, that means a minus b is 0, a minus c is 0 and a minus d is 0, then we can have the minimum value of this expression to be 0, right? For that we have to have a, b, c and d, all of them equal. Okay, so since a, b, c, d are integers and a plus b plus c plus d is 30, so a, b, c, d, they cannot be equal, right? Each of them in that case have to be 7.5, which is not possible because a, b, c, d are integers. So what I can do is, to make it very simple, I give the maximum value to any two. Maybe 28 divided by 4 is 7. So two of them can take value 7 and 7, and two of them can take the value as 8 and 8, right? So the difference will be minimum. Getting my point? Because we cannot have all the values that like a and b and c and d to be equal, because 30 cannot be distributed, it's not divisible by 4, and a, b, c and d are integers, so they cannot take the value as 7.5, right? So to minimize their difference, what I have done is I have allotted 7 to each of them, then the remaining two we can allot to any two, right? So a minus b whole square, that is 0, a minus c whole square, that is minus 1 whole square, that is 1, then a minus d whole square, again 7 minus 8, that is minus 1 whole square is 1. So the minimum value will be 2. Below that it is not possible. You can give any value to any of them, right? If a, b, c, if it is 7, it is 7, they can be 8, 8, doesn't matter, right? Answer will remain same. So that's an interesting problem from CAT 2017 paper. Now the same concept can be used in this problem. A number x is chosen at random from the set of integers from 1 to 100. The probability that that x plus 50 upon x plus 1. So x plus 50 upon x plus 1 is less than 50. So let's quickly take LCM. So, and I just shift everything to the left hand side. So here it is x square plus x plus 50 minus 50x minus 50 upon x plus 1, and it is less than 0. So x square minus 49x, okay, and 50 is cancelled, divided by x plus 1, and it has to be less than 0. So here it is x, I can take as common, then in the bracket it is x minus 49 upon x plus 1, it has to be less than 0. So just draw the line now. Here it is minus 1, here it is 0, and here it is 49. Now we want this expression to be less than 0, and since x is positive, because we can have the values of x from 1 to 100 only, right? So this expression is less than 0 from 0 to 49, right? So from 0 to 49, 1 is there, and up to 48, because 49, at 49 it will be 0. So from 1 to 48, favorable values are from 1 to 48. So in all 48 values. Okay, how many values are there in all from 1 to 100? 100. Favorable values 48, right? So 4, 12 and 4, 25. So 12 by 25 is your answer. Okay, once again I explain you. We shifted everything on the left hand side, less than equal to 0, take LCM, we draw the curve. Then from 0 to 49, the value of this expression is less than 0 because we want x to be positive only, more than 1. From 1, more than or equal to 1. So the favorable range is from 0 to 49. The integral range is 1 to 48. Okay, so from 1 to 48 there are 48 values which x can take, or n whatever x can take, out of total 100 values, right? X is from 1 to 100. So from 100 values x can take 48 values, then this inequality will be matched. So the probability is 12 by 25, right? So if your concept is clear, even this sort of questions you can do very easily. Now n square minus 38 upon n plus 1 is an integer. The maximum value of n we have to find out. As I have told you in the previous question, one more question, try to, when you have to find out this expression to be the given expression to be as an integer, then what you should do, you just try to equate, just try to find out an expression like denominator, right? So n square, I just take it as minus 1. If I have deducted 1, I'll add 1. Then minus 38, and this is n plus 1. Okay, so I just split it. So n square minus 1 upon n plus 1. So n plus 1, n minus 1 upon n plus 1. Okay, then from 1 minus 38, it will be minus 37 upon n plus 1. Okay, so n plus 1 is cancelled. This is already an integer. Okay, so we want this to be an integer. So n plus 1 should be factor of 37. Now 37 is a prime number, right? So the n plus 1 can take only one value, that is 37, right? So n has to be 36. So maximum value n can take is 36, right? So this problem is simple. I hope it is clear to you. Now square root of x square plus 16 x plus 64 to be greater than 20. So x square plus 16 plus 64 is nothing but x plus 8 whole square, right? So we can remove this square root sign with this x plus 8, the square part. So x plus 8 should be greater than 20. That means x should be greater than 20. 20 minus 8, that is 12. So the minimum value x can take is 13. That's it. Very simple. So if you are clear with this concept, you can do it very easily. Now find the integral values of x for which y is real. So since y is combination of these two expressions, so both of them should be greater than equal to 0, right? Because both the expressions are under square root. So x minus x square should be greater than equal to 0, and 3x minus x square minus 2 should also be greater than equal to 0. That means x square minus x should be less than equal to 0. So I can write it like this. X minus 1 should be less than equal to 0. Similarly, here it is x square minus 3x plus 2 should be less than equal to 0. That means x minus 2, x minus 1 should be less than equal to 0. So according to this, x should be between 0 to 1, and according to this, x should be between 1 to 2. Now since both the expressions are added, so we have to find out the common solution. So how can we do that? I draw a number line and find out the point 0, 1 and 2. Okay, so according to this, the number should be between 0 to 1. Okay, and then according to that the number should be between 1 to 2. So now we can see only the number 1, because we have less than equal to and less than equal to sign. So 1 is included in both the cases. So only number 1 is there which satisfy both the conditions, right? you can see there is no other common part. Okay, so find the integral value of x, values of x. So we just have a single value, that is 1. That's it. Okay, so this is a TITA type problem where you have to solve the problems and you just have to type the final answer. Okay, I hope you are clear with this. Find the integral values of x for which y is real. So again we want y to be real. That means the expression under the square root should be greater than equal to 0. That means x square minus 7x plus 12 by x square minus 2x minus 3 with negative sign should be greater than equal to 0. That means this expression, individually this expression should be less than equal to 0. Right? So we just factorize it. It is x minus 4, x minus 3 upon x minus 3, x plus 1, and it should be less than equal to 0. X minus 3 is cancelled out. We want x minus 4 by x plus 1 to be less than 0. So here it is from minus 1 to 4. Right? So how many integral values x can take? 4 can be included, but 1 cannot be included. Right? Because negative 1 cannot be included because that will make the denominator as 0. Right? So what are the values that we can take? After minus 1 we have 0, then 1, then 2, then 3, and 4 itself. 4 also we can take. Right? So 0, 1, 2, 3, 4, 5 values are there. Now once again a twist is there. Okay, this is again a TITA problem. So according to the solution, we have the 5 solutions, right? 5 values of x can take 5 values for which this expression will be inclusive of this minus will be greater than equal to 0. But the problem is in the previous step we have cancelled x minus 3 from the numerator and denominator, right? For simplicity, for to find out the range we have cancelled them, but we have to be very clear that x cannot be equal to 3. If x is 3, then we will have a 0 by 0 form. Right? So we have to exclude 3 from this set. X cannot take the value as 3. Right? So how many favorable values we are left with? 0, 1, 2 and 4. Just 4 values. Okay, so it's a very interesting, very important concept to understand. I hope that's clear to you. Now let's see this question. Once again a TITA problem. How many non-negative integral values x can take if y is real? That means precisely the expression under the square root is greater than 0 or equal to 0. Okay, so I just directly take LCM. So here it is 5x minus x square minus 6 by x is greater than equal to 0. So x square minus 5x plus 6 upon x is less than equal to 0. That means x minus 2, x minus 3 upon x should be less than equal to 0. So 0, 2 and 3. So x can take the values from 2 to 3, minus infinity to 0, union 2 to 3. Okay, now we have been asked about the integral values. Okay, and apart from that we can include the values also, right? Because it is greater than equal to 0 sign. Okay, so this expression can be 0 also, but over here you have to be careful that if you put x is equal to 0, there will be a 0 in the denominator, right? So x cannot be 0. So how many integral values x can take? If this x non-negative we want, below 0 all of them will be negative, but we are looking for non-negative. So how many values x can take? 2 and 3, just 2 values. Okay, so I hope this thing is clear. So in this session we have discussed some moderate level or some bit higher level questions. In our next session we'll be doing much more higher level questions. Okay, once again all questions are very well picked up, very well chosen. So just try each and every question, right? This way you will be able to practice in good manner. Okay, so I'll see you in the next session once again. You can drop your concern or if you are having any query in the comment section, and I have already provided the mail ID on which you can send your doubts as well. Okay, bye bye.